Good evening, students. Student, good evening.
Good evening, sir.
Good evening. How are you all?
Narottam, sir.
Very good. So today I am going to start a new practical. So today our practical will be a different component which is used in our VCR cycle. So last time we will completed the compressor, different compressor. So now second our component is condenser. Okay. So I will explain the condenser and its type today. So okay. So what is the main function of condenser? First of all, everybody knows there are four main components in VCR cycle. Number one, we have compressor. Number two, we have condenser. Number three, we have expansion valve, and last one we have evaporator. Last time I have already explained the compressor and its different types. Okay. Now I am going to start with the condenser. Okay. So first of all, what is VCR cycle? Everybody know when the vapor is coming from the evaporator, it's a pressure at a low pressure and in vapor state. Okay, the refrigerant will be in vapor state. Okay, then low pressure vapor will enter into the compressor where it is compressed inside the compressor and its pressure and temperature both will get increased. Okay, when its pressure and temperature both will get increased, then it will supply to the condenser. So look at here, this is the condenser. So the main function of the condenser at constant pressure, it will it will supply the heat to the surrounding. Okay, so when it will supply the heat to the surrounding, its temperature will get decreased. So there will be a phase change from vapor to liquid. When there will be a phase change, then the liquid refrigerant after passing through the condenser, it will go to the expansion valve where its pressure will get reduced when it will passing through the expansion valve, and this low pressure refrigerant then again will enter into the evaporator. So this is all about the working of this VCR cycle. Okay. So look at here, in this case, everything is given condenser discharge into surrounding. Okay. The heat is discharging to the surrounding, in which vapor refrigerant is entering into the condenser, and at the end when it will supply the heat to the surrounding, the vapor will convert it into liquid. Okay, so from compressor to up to this expansion valve, this line is known as high pressure side line. Okay, so this is the high pressure side line, and from expansion valve to the evaporator up to this compressor, this line is known as low pressure side line. Okay, so everybody know what is the function of evaporator. Evaporator absorbs the energy from the things, and it again the liquid refrigerant is converted into vapor when it is absorbing the latent heat from the space. Okay, when it is absorbing energy from the refrigerating space, then its temperature will get increased. Then your liquid refrigerant again in the last is converted into vapor, and that low pressure vapor again supplied to the compressor. So this is all about condenser. So the main definition of condenser are basically heat exchanger in which the refrigerant undergoes a phase change. In condenser, the refrigerant vapor condenses by rejecting heat to an external fluid which acts as a heat sink. Okay, so this is the definition of the condenser. Next, we have different types of condenser. Number one, we have air-cooled condenser. Number two, and under air-cooled condenser, we have two type of condenser: natural convection type and forced convection type. Okay. So next we have water-cooled condenser. Water-cooled condenser. Under water-cooled condenser, we have double pipe or tube in tube type condenser, shell and coil type condenser, shell and tube type condenser, and evaporative type condenser are also there. So in our lab, we have this cut section model of this air cooled condenser are also there. Number two, water cooled condenser are also there. And number three, we have shell and tube type condenser are also there. And evaporative type condenser model are also there in our RAC lab. So one by one, I will explain. First, I will explain with the help of this PPT. Then I will explain with the help of the models in the RAC lab. So first of all, what is natural convention type condenser? So in natural convention type, heat transfer from the condenser is by buoyancy induced natural convection and radiation. Okay, due to small airflow and low radiation heat transfer, the combined heat transfer coefficient in this condenser is small. Okay, because the heat transfer is very slow, because the heat transfer is depends upon the how much air is flowing over the pipe of the your condenser. So the COP is very small. Okay. As a result, relatively large condensing surface is required to reject a given amount of heat. So to remove more heat, so we have large condensing surface is required. So the condensing surface, the fins which is attached to the pipe is large, so that more heat is supplied to the surrounding when air is flowing on the condensing pipe. Okay. So in example, we can take the example of this type of condenser. We will use this type of condenser in our household refrigerator and in freezers and in our ACs, window type ACs. So you will see the natural convention type of condensers are also there. Okay. So mostly in our refrigerator, you will see this type of condenser is placed on the back side of the refrigerator. Okay. So in which, look at here, in which fins are also there and refrigerant is flowing through these pipes. Look at here, these are the pipe through which a refrigerant is flowing. So the vapor refrigerant is entering from this side. When it will entering through this side, it will give its heat, latent heat to the fins, which is attached to the this pipe. So these fins are known as condenser. So this arrangement is known as condenser. Okay. So when it is your refrigerant in the form of vapor will flowing through this pipe, it will continuously give its heat to the fins by radiation or through conduction. Through conduction, it will give its heat to the fins, and fins will give its heat to the surrounding when the air is flowing on the fins. So if the area of the fin is large, so the large amount of heat will flow. If the area is less, then less amount of heat will flow to the surrounding. So this means when it will continuously flow through this pipe, it will continuously give its heat to the fins through conduction, and the fins will give its heat to the surrounding through convection method. So at last, when the your refrigerant is reaching at the last, then it will completely converted into liquid refrigerant. So from here, the liquid refrigerant is coming outside, and this liquid refrigerant is again supplied to the expansion valve. Okay. So this is the natural convention type. Next, we have uh, uh, forced convection type condensers are also there. So in forced convection type condensers, the circulation of air over the condenser surface is maintained by using a fan or a blower. The condenser normally use fins or air side for good heat transfer. The fins can either plate type or annular type. Okay. Phrase forced convection type condenser are commonly used in window type air conditioning. Okay. Water cooled and packaged air conditioning plant. So look at here in forced type convection type condenser. So look at here, the again vapor is coming from the condenser. When it will coming from the condenser, it will give its heat to the again to the fins, okay, which is attached to the pipe. But to uh, to circulate more air over the surface of the pipe, we will arrange a fan behind the condenser. so it will throw more air on the pipe, so more heat will be transferred to the surrounding. So in this case, the COP will be more in transferring the heat to the surrounding as compared to the convection type condenser. Okay. So look at here, motor is there, which is used to rotate the fan, and fan throwing more air on the tube, and through tube, when air is moving through the fins, it will transfer more heat to the surrounding. Next is your look at here, plate type condenser are also there. In a plate type condenser, what will happen when your vapor is coming from one side, it will continuously, because it is attached to the plate, and it will continuously give its latent heat to the plate, and plate is directly contact with the air, and it will supply the air to the surrounding. So these days, this plate type of condensers are there in your refrigerator. So in your new models, there is no such type of condensers are there. Conventional type of condenser are not there, but this plate type of condensers are there. Okay, so these type of condenser, conventional type are replaced with this plate type of condenser. Okay, so next we have double tube water cooled condenser. So look at here. In this case, double tube water cooled condenser. There are two pipe. One is outer side, two diameter pipe. One is outer side diameter, and through which another pipe. So this type of arrangement is known as double tube water cooled condenser. So look at here. In this case, water is coming from the lower side, and it is continuously moving to the upper side. Okay, so this is the inlet of the water from lower side. So look at here, and the vapor refrigerant from the compressor is coming from the upper side. So look at here, the red area is your vapor which is coming from the your compressor. Okay, so when it is moving downside, look at here, when it is continuously moving downside and water is coming from lower side to upper side, it will continuously give its heat to the water. So this type of removing the heat is known as convection method. Okay, by convection method, it will continuously give its the refrigerant will continuously give its heat to the water, which is flowing in opposite direction. So look at here, water is flowing from lower to upper side, and refrigerant is coming from upper side to the lower side. So when refrigerant is coming from the upper side to the lower side, then it will continuously removing its heat to the, it will continually gives its heat to the water. And when it will reach at the end of this pipe, then the vapor refrigerant which is coming from the compressor is completely converted into liquid refrigerant. So the liquid refrigerant at the end of this double tube water cooled condenser, then liquid refrigerant coming outside, and then this liquid refrigerant is supplied to the expansion valve. So this is type of a double tube. This is the double tube water cooled condenser. So how it will work, I have already explained. Okay, next we have shell and coil type condenser. So look at here, in which shell and the refrigerant is coming inside through this shell. So look at here, this is the shell through which a coil is there, in which cooling water is coming inside and going outside. Okay, so again, through this is again a plate type shell and tube type condenser, in which water is coming flowing from this lower side, and it is completely rotated through this coil and moving outside from the upper side. And in this case, liquid your vapor refrigerant is coming inside through the upper side, and when it will coming in contact with this coil, then it will continuously give its latent heat to this coil. Okay, so when it will continuously give its heat to the these coils, then your vapor refrigerant which is coming from the upper side is completely converted into liquid. Okay, liquid refrigerant. So what is the difference between sensible heat and latent heat of vaporization? So in sensible heat, there will be no any phase change. Only there is a temperature difference from temperature will decrease from 80 degree to 60 degree, and there will be no any phase change, then this type of change in temperature, that is known as sensible heat. Okay, but latent heat, in which if I will take the example of water, if I will boil the water, and if I boil the water above 100 degrees centigrade, then what will happen? The temperature is also increase, and there will be also a phase change from water to the liquid. Okay, so the water is converted into liquid or vapor phase. So water is converted into vapor. So there will be a phase change in your latent heat. Okay. So in this case, look at here, when vapor refrigerant is coming in contact with these coils, it will continuously give its heat to this coil. So when it will give its heat to this coil, when continuously moving to the lower coil, it will continuously give its latent heat, sensible heat to the coil. Then at the end, your vapor refrigerant is converted into liquid refrigerant. Okay, and the water is coming from one side and it will continuously moving to the other side. So this type of condenser is known as shell and coil type condenser. Next, again, look at and here another type of shell and tube type condenser, in which, look at here, this type of arrangement there, in which a tube are there in which water is flowing. So look at here, these tubes are there in which water are flowing. The water is coming from the lower side. Look at here. So these all arrangement, the area, these all known as shell, and the inner side is called tube through which water is flowing. Okay, so the water is coming and it is continuously flowing from this tube to the other side. Okay, so this means water is coming from the lower side and it will continuously move through this pipe and continuously going to the other side. And look at here, from shell inlet, the refrigerant is coming inside. So look at here, the baffle plates are also there through which your refrigerant is continuously flowing over these pipes. When your refrigerant is continuously flowing over these pipes, then it will continuously removing its latent heat and giving its latent heat to this pipe. And when at the end, the liquid refrigerant is collected at the bottom, and that will be supplied to the expansion valve. Okay, so in this case, again, vapor refrigerant is supplied from the upper side and liquid refrigerant is collected at the lower side of this shell and tube type condenser. Okay, so this type of condenser is mostly used because it has a higher rate of removing rate of heat transfer is there. So this type of shell and tube type is mostly used in big industry, in oil refinery. Okay, so where tonnage capacity is very high. Okay, so next we have, and the last one, we have this evaporative type of condensers are also there. So this evaporative condenser model we have already in our lab. I will show you in when I will go to the lab. Okay, and I will show the cut section model of this evaporative type condenser. So in evaporative type condensers, both air and water are used to extract heat from the condensing refrigerant. Okay, so in evaporative condenser, both air and water we will use to remove the latent heat from there. Okay, so in these condenser, the water is sprayed from the top part of the bank of tube carrying the refrigerant, and air is induced upward. So in this case, the water is flowing from upper side and it is throwing on the pipe in the form of mist. Okay, through shower. Okay, through nozzle. When it will throw on the pipe, then what will happen? It will take away the, when water is flowing over the tube, then the evaporative cooling take place. Okay, then water is flowing on the hot pipe, then evaporation process will be there. When evaporation process will be there and air is coming from the lower side to the upper side. Water is coming from upper side to the lower side. So this means the condenser pipe is cooled with the help of water as well as your air which is flowing from lower side to the upper side with the help of a fan. Okay, so a fan is also placed on the upper side of this evaporative type condenser. So evaporative type condenser will drawing the air from the lower side to the upper side, and water is throwing from upper side to the lower side with the help of nozzle. When water is flowing over the pipe, it will get evaporate. Okay, then when evaporation process will be there, then remaining is it produce a cooling effect. Okay, and the the water which is already get heat from the hot pipe of refrigerant, then it will cool with the help of the cooled air which is flowing from lower side to the upper side, and that cold water again stored in the tank, and that water is again and again circulated over the pipe. So the transfer coefficient of such type of evaporative condenser is very large as compared to other type of compressor. Why? Because in which the water and air both are using. Okay. Hence, the refrigeration system can be operated at a low condensing temperature. So look at here. This is the diagram of the evaporative type condenser. So look at here. The fan is there at the upper side of this condenser, which is withdrawing the air from the lower side to the upper side. Okay. Then sprayer nozzle is there. Look at here. These are the sprayer nozzle. Okay. And these are low at the lower side. Water tank is there. With the help of pump. Okay. When water is flowing from with the help of pump to this nozzle, it will throw the water through this nozzle on this pipe, and it will take away the heat from there. Okay, and it will take away the heat from there, and the air which is coming from the lower side, and it also take away the heat from the this cooling condenser coil pipe. Okay, so this means the heat transfer rate is very large in this case. So this type of condenser is mostly used in big industry where large amount of heat transfer is needed. So this type of condenser in which both water and air is used to cool down the refrigerant. So this type of condenser is known as evaporative type condenser. Why it is called evaporative? When water is flowing, throwing on the tube, and the refrigerant which is flowing through these tubes are very hot, and when cooling water is coming in contact with this tube, it will get evaporate. That's why its name is known as evaporative type condenser. So beta, this is all about your condenser. Okay, now I am going to the lab where I will show the cut section model. Okay, so everybody don't shut down your Zoom. Now I am going to the lab where I will show you the cut section model of this condenser. So we have this type A, 4 type condensers are also there. A shell and tube type condensers are also there. So look at this A tube type condenser. You will see your tube type condenser. And look at the vapor which is coming from the your compressor. When it will moving from lower side to upper side, it will continuously give its heat to the these things. So these are called the fins, and this red area in which vapor refrigerant is coming from your compressor. Okay. So when a vapor refrigerant is coming from the compressor, it will flow through this tube. Okay. When it will, and these fins are attached to this tube. Okay. So these fin, when it will continuously moving its latent heat to these fins. And when it will moving its latent heat to these fins, it will give its heat to these fins with the help of conduction method. Okay, by conduction method. And these fins, when it is coming in contact with the air, and when it will continuously coming in contact with the air, and it will continuously give its heat to the surrounding. Okay, so this is how it will transfer its heat from refrigerant to the surrounding of these things. So this type of things type. Okay, in force there is a fan which is playing tube. Okay, and helping forcing more air to move over these pipes. Okay, so that will help to move more heat. If that the removing of heat is also depend on the area of this piece. If the area of this piece is large, then more air will come into contact with this piece and more heat will be transferred to the surrounding. Okay, so in our window type air conditioning, more air will be supplied over this pipe. So more air will be supplied to the surrounding. So the COP in such case will be large as compared to the simple convection type condenser. I will talk about the simple type of condenser. So this is known as simple type of condenser, which is using in old refrigerator. In older refrigerator, you will see such type of condenser was there. Okay. So in which look at here, the hot vapor is coming through, is passing through these pipes. So look at here. These are the pipes through which the vapor refrigerant is. So this red area is the vapor refrigerant which is coming from this compressor. Okay. So when vapor refrigerant is coming from this compressor, it will continuously give its heat to these things. Okay, which is attached to the pipe. So when natural air is flowing over these things, then it will continuously give its heat to these things by conduction method, and this at the end of this pipe, it will convert into vapor, liquid refrigerant. So this vapor refrigerant is coming, and it will continuously give heat to these fins, and these fins continuously give heat to the surrounding by convection method, and it will continuously give heat to the surrounding, and last the vapor refrigerant is converted into liquid refrigerant. And then this liquid refrigerant again supplied to the expansion valve. Next, we have this the section model of the shell and tube type of condenser. So look at here. So this from here, the your refrigerant is coming from the upper side, from the your compressor, and it is flowing. The refrigerant is the vapor form is supplied to the expansion valve through this at the bottom through this hole. Okay, the pipe is attached, and from here, because and look at here, the water is coming from one side and it's coming back from the other side. Okay, so through these pipes, water is flowing. Okay, so when the water is flowing, when it is coming from one side and is going from the other side, it is continuously coming from one side and going from another side, and the refrigerant in the vapor form is coming from the your compressor. Okay, so when vapor refrigerant is coming from compressor, it will continuously come into contact with this pipe through which water is flowing. Okay, when it will come into contact with this pipe, then it will continuously give its later rate to this pipe through which water is flowing by first conduction, then convection method. Okay, so then conduction method. Okay, then what will happen? By convection method, it will continuously moving its rate. Then vapor refrigerant converted into vapor refrigerant. That will be collected at the bottom of this shell, and that liquid refrigerant again supplied to the your expansion. So this type of is known as shell and tube type. Okay. Next we look at here. This is the model of evaporative type condenser. In evaporative type condenser, there is one fan which is used to bring the air from the bottom side to the upper side, and there is one limiter which do not allow the water to go outside with the help of the moving fan. Okay, when moving fan there, then look at it at the lower side, nozzle is there. In this model, this shower is replaced with the nozzle. Okay, through which when water and this is water tank. Look at here at the bottom side of this evaporative type condenser. This is the water tank, in which motor pump is also tank. Water pump is also tank, through which circulates the water through this nozzle. Okay, so when whole vapor refrigerant is going through this condenser, so this is the condenser. Look at here. This is the condenser. So through which this is the thing from the compressor, high vapor pressure temperature, vapor is coming through this pipe. So look at here, the red area, through which hot vapor is coming from the compressor. Okay, when it is passing through this pipe, then water is flowing on this pipe. When water is throwing in the form of mist, then in the form of fine droplets, then it's coming into contact with this pipe, then what will happen? It will get evaporated. When water get evaporated, then the remaining fact will be cooling again. Then it will produce cooling, more cooling over the pipe. So it will produce more cooling over the pipe, and when this fan is rotating, moving, then when fan is rotating, then it will be drawing more air. Then air is also coming into contact with this condenser pipe. Okay, so this means these condenser pipe is cooled with the help of water as well as air. And when water is throwing in the tank, then it will also coming into contact with the air which is withdrawing from the lower side. Then the water which is collected inside the tank is also cooled with the help of air. Or why it is removing its heat to the surrounding when air is flowing over the water droplet. When air is flowing over the water droplet, then it will also continuously moving its liquid. Then the water which is collected at the bottom of this tank will be cooled one. Okay, so that cooled water is the main supply over this through this nozzle over the surface of this condenser. Then this type of condenser is known as evaporative type condenser, in which both air as well as water is used. So the COP such type of condenser is very large. So such type of condenser is using mostly in power industry. Okay, in a chemical industry, in a big industry. So this, okay, so this is all about condenser which we have in our RAC. So thank you.